So our first lesson of the new year is about arithmetic and geometric sequences. I want y'all to say that because it looks like the word arithmetic. Y'all see how this looks like the word arithmetic? Yeah. It's not arithmetic, it's pronounced arithmetic. So y'all say that, arithmetic. And this is geometric. But honestly, we're just doing sequences, and all sequences are patterns of numbers. So we are literally dealing with patterns today. Can we do that? There's two types of patterns. One of them is called arithmetic and one of them is called geometric. We're going to identify terms in these sequences and try to use equations or use the patterns to make more terms. Okay? The first type of sequence we're going to talk about is, again, our arithmetic sequences. When we're using arithmetic sequences, all we're doing is adding or subtracting to make the pattern. That's it. Some vocabulary that goes along with this. Its pattern is called the common difference. We find differences by subtracting. Difference means subtract. So if we're struggling to figure out what the pattern is, you just need to subtract the numbers. Okay, it's called a common difference. It's represented by the letter D for difference. It's when the pattern between all the numbers is the same. Now, what you need to know about sequences is it looks really funky, but this is just a way of telling you the order of the numbers. Since this says 1, what number in my pattern is that? The first term in my pattern. So what we could do is we could also write this as 5, comma, what number's next? 9, comma, what number's next?
13.
What number's next?
17.
Cool. You see how that works? Yeah. Now, since those are patterns of numbers, they go on for forever. So like actually at the end of them, you do put this comma, dot, 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 the ellipses, because it keeps going on for forever. So all we've done is taken the sequence that they gave us and we put it down just in pattern order. Now just looking at these numbers, can you tell me how I got from 5 to 9?
4.
Did I add 4 or subtract 4?
Well, add 4.
Okay, now if I go from 9 to 13, what did I do?
Add 4.
And from 13 to 17?
Add 4.
So that is going to be my common difference, 4. That's the pattern. We're just adding 4 every time.
So if you're like subtracting, it's going to be minus 1?
That's correct. If we are subtracting, your common difference would be a negative number.
Well, this is just as easy as X on wait. Oh.
All you're doing is adding the numbers, adding a number to each one to make a pattern.
Cool.
Uh-huh. Now let's make sure that makes sense though. So let's go down a second. And I want you right now on number 1 to find the pattern. First thing that might be helpful when we're finding the pattern is to write it down just as the numbers in the pattern instead of with the subscripts that tell us the order. So this pattern is 3, 8, 13, 18, and on and on. It's plus 5. Yeah, so from 3 to 8, I had to go plus 5. From 8 to 13, I had to go plus 5. From 13 to 18, I had to go plus 5. So this is an arithmetic sequence because we had to add. And the common difference is that number 5. But it goes on to ask me to find the next 3 terms in the sequence. Okay, so if I knew that a sub 4 was 18, what's a sub 5?
23.
How'd you get 23?
Adding 5.
Adding 5 to what?
18.
18. I just added 5 again. Okay, so what about a 6?
What? 28.
How'd we get 28?
We had 5.
We added 5 one more time. And the next term in the sequence, the 7th term in the sequence would be?
33.
33. So we just use the pattern of plus 5 to make more numbers in the sequence. Yes?
Oh, so after you get like the ones that it gives you, just do the next 3?
Oh, yeah, I can just keep the pattern going to find the next 3 numbers. Yeah, exactly. Okay, so that's the first type of sequence that we're going to have. The second type of sequence is called geometric. Geometric sequences are not found with addition and subtraction. They're found with, what does it say? Multiplication and division. But I want you to say, cross out the word divide, and I want you to say multiply by a fraction.
So it's literally the same thing with different equations.
Just like adding a negative with subtracting, multiplying by a fraction is dividing. And that's true in all cases of dividing. It's just multiplying by a fraction. This time the vocabulary changes. It's now called a common ratio instead of a common difference. It's going to be represented by the letter R. That's going to be the pattern that we're talking about. Since it's not adding or subtracting, it's not a difference anymore. It's called a common ratio. Okay, so we look at the pattern they gave us. They gave us 4 terms. The first one is 5, and then 15, and then 45, and then 135. What's happening every time? We're multiplying by? How do I get from 5 to 15? Times 3. How do I get from 15 to 45? Hopefully. Double check me in your calculator. Is 15 times 3 45?
Yes.
How about 45 times 3?
Yes.
If that number is not the same the whole way across, something's wrong.
Wait a minute.
So double check it. Are you sure?
Yes.
Yes? Okay, so that means the common ratio is what number?
Times 5.
3 times 3.
So it's just,
Yeah,
you
so
have to put the thing, right?
no, you don't have to put times because a common ratio already tells me I'm multiplying by 3. Common difference told me I was adding the numbers. Common ratio tells me I'm multiplying that number. And that's all we're going to have to do to find more numbers in that pattern, in that sequence.
How do you write it if it's dividing?
You would say times a fraction, like times 1/2 would be dividing by 2. Times 1/3 would be dividing by 3.
Subtraction.
If for the common difference, it would just be negative. Yes. Okay, I want you to make sure we understand this with example 3. In example 3, let's find the pattern. First things first, it might be easier just to take the numbers out of the notation that they're given. So the first term is 2, the second term is 4, third 8, fourth 16, and on. What's happening every time?
Times 2.
Times 2. To get from 2 to 4, I had to multiply by 2. And from 4 to 8, times 2. And from 8 to 16, times 2. So that means that this is a geometric sequence, and the common ratio is 2. Now, how would I find the next terms in this sequence?
Times 2.
What times 2?
16 times 2.
So we take the last number in the sequence and we multiply it by the common ratio. So that means the next term in the sequence, a sub 5, would be 32, 16 times 2. And then the next one,
64.
how'd you get 64? 32 times 2. And a sub 7? 128. That's 64 times 2. So you're just using the pattern over and over again. Really not a big deal, right? It's just a pattern.
I don't trust it.
Yeah, I don't trust it. Okay, that's a good point not to trust it, because here's what I'm going to do on the next one.
Oh my God.
You have 2 examples here, example 2 and example 4. I'm not telling you which ones they are. I need you to figure out if they're arithmetic or geometric.
Miss, that's what I was gonna ask.
Ooh, how do we do that?
Yeah, I was gonna ask you, how do we tell the difference?
Addition and subtraction.
So Adrian's right. If you can find a pattern by adding or subtracting a number all the way across, it's arithmetic. If you can find a pattern, maybe addition and subtraction didn't work, try multiplication and division. If you can multiply or divide by the same number to get to every other number in the pattern, then it's geometric.
It's really not hard.
I want you to think about it. I know it's a little bit of a stretch because like cobwebs in the brain for the last 2 weeks, but give it a second. I want you to try. Okay, so I'm seeing that we understand for example number 2. A lot of you guys wrote down the pattern and then realized, minus 6, minus 6, minus 6. So that's an arithmetic sequence where the common difference is negative 6. I saw that across the board, so very good. And then if we wanted to keep the pattern going, to get the 5th term, be negative 17, minus 6. And then minus 6 again to get negative 23. Very good, thank you. Okay, so for the next one, I get why this next one is confusing, because you have to kind of think harder. And the cobwebs on my brain really feel like something. So if I do this and I start by subtracting, how do I get from 40 to 20 if I subtract? If I subtract though. And then from 20 to 10. And then from 10 to 5. Are those the same numbers across the board? So is that my pattern? No. So that's not going to work. So let's try to use addition or multiplication or division. You already said it out loud. How do I get from 40 to 20?
Divide by 2.
divide by 2, which means multiply by a half. Divide by 2 again, from 20 you'd get 10. Divide by 2 again, from 10 you'd get 5. So if that happens and then that's good, what kind of sequence is this?
Wait, and we going least?
Y'all are confused because she said multiplying by 2 is the same as, dividing by 2 is the same as multiplying by 1/2, right?
Is that where I lost you?
Yeah.
Okay, so let me back up for a second.
Miss,
So-
is we going least to greatest to greatest to least?
What do you mean?
So you put 40 up front, I put
Left to right.
Okay, look, so this is the first term and it says 40. This is the second one, it says 20. That's the order I'm going in. Not just whatever order I want. It tells me the order 1, 2, 3, 4. That's what those little numbers are for. It's the order of that they go in. That was a really good question, actually. So you probably all wrote down this then, is what I'm hearing. Divided by 2. Divided by 2. Divided by 2. I mean, that's like technically correct. But what I want you to say is if you had told me that the common ratio is 2, that means you're multiplying by 2.
You say divided by 2?
No, you have to tell me a number. The number that tells me to multiply so that it gets smaller has to be a fraction.
I get it.
And all you do is take that number that you're dividing by. You said divide by 2, right? You said divide by 2. Okay. Divide by 2. This symbol right here, I'm about to get on my soapbox. This symbol right here is totally misleading. Did you realize that it's actually a fraction with placeholders? So if you say divided by 2, okay, so the 2 goes down there. And what do you put in the top when there's nothing? 1.
Wow.
What?
Wow.
Fractions are just division. What? I know.
Okay,
I thought it was the symbol.
maybe this picture will help. If you have a pizza, a whole pizza, and you divide it by 2, you have 1/2 and 1/2, right? That's the same. That's how you get the fraction. If I were to divide it by 4, or have 4 pieces and times 4, or divide it by 4, I would have 1/4.
4.
Well, mind blown.
Mind blown. Yeah, that symbol for division is very misleading and you get stuck on it being a symbol. It's literally just a placeholder for a fraction. So the number that you went after, it goes in the denominator. That's the fraction that you make. So yes, divided by 2 is what you're saying, but you write down that the R value is 1/2, which tells me I'm dividing by 2. Okay, cool. So that means that this is also geometric. That's fine. I accept geo. Now, if I wanted to find the next 3 terms in this sequence, I need the 5th term. What would I do to find the 5th term? 2.5. So 5 divided by 2, or 5 times 1/2, is 2.5. A sub 6, so 2.5 divided by 2, or times a half. And then A sub 7 is 1.25 divided by 2. Isn't it 625? 0.625? Oh my gosh, check my math. Is 1.25 divided by 2.625?
Oh, yes.
Is something new on here? Oh my lord.
Okay, so we're good to go.
You're right.
Thank you. Now that we've talked about sequences, what kind they are and how to use them, we're going to use a formula to create more numbers in the sequence. This is called a recursively defined formula. What that means is it gives you the first term, and then it tells you what to do for every term after that.
Oh, so it's like the F
Are you
of
sure this
whatever,
is math?
that F of
Sort of, yes. So this is pronounced for the arithmetic sequence here. It's pronounced, and I don't really care that you know how to pronounce it because we're just going to use it. It's called A sub n is equal to A sub n minus 1 plus d, given A sub 1 is equal to some number. Here's what I care about. I know, that was all English. That was all English, too. Here's what I want you to care about.
Miss, can you say one more time?
A sub n is equal to A sub n minus 1 plus d, given that A sub 1 is equal to some number.
Okay.
Okay.
Okay, here's what I care about. We talked earlier that arithmetic meant that we were going to add. Guess what number we're going to add every time in this pattern?
Oh,
That's all I care about is that number.
Wait. So
you don't have to change the A or the 1?
Nope, don't care about it. I need you to figure out the pattern. The pattern is
So that
D.
first one right there, we just gotta add 3.
Literally, yes. So, and it gives you what the first number is. So if this is the first number,
A sub 1 is your first one.
and then what you're going to do after that is add this number.
Oh.
That's it.
They just
So
We
write
don't
it.
know that number.
That one just says number.
You will be given that. You have to be given the first term, you have to be given the pattern, or else that's not what this is. So if we look at this example here, it says a sequence can be generated by using a sub n equal to a sub n minus 1 plus 3, where a sub 1 is equal to negative 3, and is a whole number greater than or equal to 1. What are the first 4 terms in the sequence? There's a lot of words going on there, but what do you see right here?
Plus 3.
So what are you going to do with 3?
Add 3.
We're going to add 3 every time. And what are we going to start with?
3.
Are you sure?
Negative 3.
Negative 3. It says the first number is negative 3.
Oh, I know that's the answer.
It's not counted.
Hold on. We're going to make this a little bit different today. We're going to put them into a table. A table. So here's my table. It wants the first 4 terms in the sequence. So 1, 2, 3, and 4. But guess what? They already gave me the first term in this sequence. What is it?
3.
Negative 3. And what am I going to do to create the other numbers in this table?
Add 3.
Okay, so negative 3 plus 3 is, and then 0 plus 3 is, and then 3 plus 3 is. Okay, great.
Wait. Oh.
So we started with the first term in the sequence, which they gave me. And then I used the pattern of adding 3 each time to finish finding more terms in the sequence.
I seem to understand the pattern now.
You seem to understand the pattern. So here's how I want you to write the answers, though. I want you to write it back in the correct notation, which means what is the first term in the sequence?
Negative 3.
Negative 3. What is the second term in the sequence?
0.
Do you see how I'm writing that with the A and then the little subscript to tell you what number in the sequence? Okay, so what's the next thing I'm going to write down?
3.
Plus 3.
A with the little 3, it's called A sub 3 equal to
Oh.
3. And then A sub 4 equal to?
6.
Very cool.
Do we still need to add the 3 extra ones?
The little dot, dot, dot?
No, because you said on the other side.
That's a good question. Look at the actual question in the problem here. It says, what are the first 4 terms in the sequence?
Oh, 3.
1, 2, 3, 4. Those are the first 4.
So that's it.
That's it.
And
Yes.
you just write it down?
So let's say, what does it say? It's the first 6.
So you give me 6 numbers, yeah.
It's like 1, 2, 3, 4, 5, 6.
Yep.
You know what?
Yep. Okay, I want you guys to practice this with the one right underneath it. Go right underneath it. I want you to practice with this one.
If it said minus.
All right, I'm seeing a lot of people finished and or stuck, so let's talk about it. It says a sequence can be generated by using a sub n equal to a sub n minus 1 minus 4, where a sub 1 is 2 and n is a whole number greater than 1, blah, blah, blah. What are the first 4 terms in the sequence? Okay, I want the first 4 terms in the sequence, so I'm going to make a table with 1, 2, 3, and 4, the first 4. If it asked you first 5, you'd put a 5th row. And if it asked you the first 7, you put 7 rows. Rows. I don't know why I said rolls. I'm hungry, I guess. Now, if we look at this pattern, what is the pattern telling me to do for every number?
Subtract 4.
Subtract 4. So my number should be getting smaller. And what am I starting with? 2. Okay, so 2 goes here. And then to find the next one, I'm going to subtract 4. What is 2 minus 4? And then I'm going to do it again to find the next number. And then I'm going to do it again to find the next number. Nice. So we followed our sequence pattern so that a sub 1 is equal to 2, a sub 2 is equal to negative 2, a sub 3 is equal to negative 6, and a sub 4 is equal to negative 10. That's my sequence.
This is so hard.
Okay.
Now I'm a pro.
Cool, cool, cool. So that's not the only sequence we have, though. We didn't just add and subtract on the front page. What else did we do? All right, so our geometric sequences look like this. They say a sub n is equal to r times a sub n minus 1 given a sub 1 is equal to some number. Where's my common ratio, though? That's an r value. So all I really need is this number right here. That's what I'm going to multiply by. So again, this is the first term, the first number, and we'd multiply by whatever this number is. In the first example, it will be this. Will be 5, sorry. I'm writing the word this, so I said it out loud. So, like you guys said, in this first problem, what am I multiplying by? 5. And what number am I starting with?
8.
Okay, great. So I'm going to make my table for the first 4 numbers in the sequence. 1, 2, 3, and 4. It starts with what number again? 8. And then I'm going to multiply by 5 to make the next number, which means it's 40. Then I'm going to multiply by 5 again.
200.
And then I'm going to multiply one more time.
Yeah.
Mhm.
It's 2 times 5 is 10.
So it works just the same. You have to notice the difference between the sequences, but it's really easy because the arithmetic one literally says plus or minus. So you're going to add or subtract. And then these two numbers are smushed next to each other, so we know we're going to multiply. To finish this out, we write down our final answer. A sub 1 is equal to 8. A sub 2 is equal to 40. The third term is equal to 200. The fourth term is equal to 1,000. That's it. If it asked you for more or less terms, that's how many answers you would give me. Now I want you to do the next one. Don't panic when you see the next one.
Oh, come on.
You're already panicking. What am I multiplying by every time?
You're not multiplying by
I'm either multiplying by a half or I am dividing by. Both of those are the same thing. That's all I'm going to say. I want you guys to finish this next problem. You got it. I believe in you. Okay, I'm seeing really good stuff. Here's what I'm seeing. I'm seeing that a lot of people set me up a table with the first 4 terms in it. Love that. And they said the first term is 80. Okay, I either saw multiply by a half or divided by 2. I like this one better, but both are acceptable because they're the same thing. And when you divide that by 2, you'd get 40. And then when you multiply by a half, you'd get 20. And then when you multiply by a half, you'd get 10. So the first 4 terms in the sequence are 80, 40. That's the number 2 again. 10. Nope, I missed a number. That's embarrassing. Classic. Not me making mistakes. What?
Miss. That's 'cause once you attach it, you can't take it off.
Okay, so that's the end of our notes for today. We are going to do one more collaborative moment in a second.